Hello, today we're going to start our work in trigonometric identities, and we're going to start off by doing the trigonometric function version of Pythagoras, and then we're going to look at some identities. So what we've got here is the unit circle that we already know very well, and I have drawn in my hypotenuse, or my radius of my circle is 1, and it's also the hypotenuse when I do my coordinates for x and y, because this is at the origin 0, 0. This distance here across is x, this distance here is going to be y. So if I look at my relationships, I have cos theta would be equal to, cos is equal to the adjacent over the hypotenuse, which is going to be x all over 1. So x would be equal to 1 multiplied by cos theta, which we would just write as x is equal to cos theta for the unit circle. And sine theta would be equal to opposite over hypotenuse, which would be y over 1. Rearranging, we'd have y is equal to 1 multiplied by sine theta, multiplying both sides by 1. This is just a by the way, because you can do this with any hypotenuse, and just remember that you would multiply by the hypotenuse. So y would in general be equal to the hypotenuse multiplied by sine theta, or as we've written it here, the radius multiplied by sine theta. This will be important at other stages in the course. So this is our relationship for x and y. And then we're able to apply that to the fact that it works for a right angle triangle. So these are x's and y's for a right angle triangle. So this is our x, and this is our y, and this is our theta. Well, I know that and 1 is my hypotenuse. I know that y is equal to sine theta. X is equal to cos theta. Therefore, the relationships that would hold for a right angle triangle are going to still hold here. So we have the hypotenuse squared would be equal to a squared plus b squared. The hypotenuse is 1, so 1 squared is equal to a is cos theta. To be squared plus sine theta is y, is b to be squared. So I end up with 1 is equal to cos squared theta plus sine squared theta. A little bit of a notational reminder, the little 2 going up here is where we put the square instead of having to write these brackets all of the time. So the square does not go out here on the bracket, the square goes over the cosine and the sine. So just keep track of that. We don't write the squared out here, we write it over the cosine and the sine, because it is the function that's squared and not what's inside of the function. Now, this is an extremely important relationship, and you will often use it in a slightly different fashion, but to point out, anytime you see cos squared, sine squared, or 1, when you are doing stuff involving trigonometric identities, you are often going to use some version of this as a substitution. So we could rearrange this formula to say that cos squared, or cosine squared, would be equal to 1 minus sine squared theta, or sine squared, likewise, rearranging our original formula, would be equal to 1 minus cosine squared. These three relationships come up very regularly, so they should always be in the back of their mind. It's a bit like difference of two squares in algebra. We should always have it in the back of our mind. We should always have these three relationships in the back of our mind as well. Now let's put them into practice with this trigonometric identity here. So I have 1 minus cosine squared theta all over tan squared theta plus sine squared theta is equal to 1. Now I've got a 1 here which immediately makes me think, could I be dealing with my Pythagoras, my trig Pythagoras? Because I see the number 1. Now, I'm not sure, but what I'm going to do in general is convert everything I'm given into cos's and sines. So I've got a tan squared here. I'm going to turn it into sine squared all over cosine squared. Now, those relationships that we're going to need are on page 13 of your log tables. So the second you see a trigonometric identity, we should be taking out our log tables to page 13. And 13 up to around 16 is going to be very regularly used in this type of work. So I have a 1 minus cosine squared. Now we've just done a situation where we have a 1 minus cosine squared, so I'm going to make this substitution and say that this is probably going to be better off as sine squared theta. Tan squared is sine squared all over cosine squared. Again, everything we can, convert it into sines and cosines, and then simplify as much as you're able to. I'm not going to do anything with this 1 because I'm going to see if I can turn this mess into something tidier. If I need to convert it, say into cosine squared plus sine squared, I can, but I'm going to leave it alone if possible. So I'm going to try and get everything over on this side converted into sines and cosines. Now I'm dividing by a fraction here. So what I do is flip the fraction and multiply. So I have sine squared theta multiplied by, flip the fraction, so cosine squared theta all over sine squared theta plus sine squared theta. Now I can see that I have a sine squared divided by a sine squared, so they're going to divide out, and I'm going to be left with cosine squared theta plus sine squared theta is equal to 1, and I know that this, my trig version of Pythagoras, or my trig function version of Pythagoras, this is equal to 1, and I'm able to state that. So 1 is equal to 1. So that works out. And that's the job done. So again, general principle, if you see something like this, you're going to convert everything into sines and cosines and try and simplify it down. And 9 times out of 10, that is going to get you everything you need. And again, page 13 in the log tables is your main piece for that type of work. Now, if we don't just have sines, cosines, and tans and secants and things like that, if we have sides as well, so if we have A, B, or C, these are the sides of our triangles, if we remember back to our previous work in trigonometry. If we have stuff involving sides and stuff involving sines and cosines, that means we are almost certainly dealing with the sine rule or the cosine rule, and that's on page 16 in your log tables. So A all over sine A is equal to B all over sine B is equal to C all over sine C. Just to point out, you can rearrange that for a substitution. You could rearrange this formula to have sine A is equal to A sine B all over the side B. Or likewise with the cosine rule, you could rearrange the cosine rule here to have cos A is equal to all of this. And that's usually how you're going to use the sine rule and the cosine rule. You're going to do a substitution to try and simplify things down. Case in point, we have C is equal to the side B multiplied by cos of the angle A plus the side A multiplied by a cos of the angle B. I have sides and angles both in the same question, so that tells me I'm using either the sine or the cosine rule, and the fact that I have cosines going on tells me I'm using the cosine rule. So I'm going to write down what cos of A and cos of B are equal to, sub them in, and see if I can simplify it down to C. So I have cos of A, I already have written here. You would write down your cosine rule and rearrange it, which you are all able to do, simple algebraic reorganization, 2bc, cos of b, when you rearrange it, is going to be e minus b squared plus a squared plus c squared all over 2ac. It's important that you do these before you try and sub in. There's a lot of algebra going on here. Make sure that you aren't trying to do it from your head. Do the rearranging beforehand. So we have c is equal to b on minus a squared plus b squared plus c squared all over 2bc plus a on minus b squared plus a squared plus c squared all over 2ac. I see that I have b divided by b here. So I'm going to divide out my common factor, and a divided by a here. So I end up with c is equal to, I now have a common denominator, so I can write these fractions added together. A squared plus b squared plus c squared minus b squared plus a squared plus c squared all over 2c. c is equal to, gather your like terms. So I have a minus a squared, a plus a squared, a b squared, and a minus b squared, and a c and a c. There's a lot of algebra going on here, so we'll use some symbols to keep your life easier. So I end up with 2c squared all over 2c. See, I have common factors that I can divide out, so I end up with that equal to c. c is equal to c. That's indeed true. So that is all I need to do there. So, in general, we are going to look for, if we have sides and cosines or sines, you're going to use the sine and cosine rule to do a substitution to simplify things down. That's sine and cosine rule are on page 16. Otherwise, for the most part, we'll be working with page 13 in the log tables to convert everything into sines and cosines and simplify down using algebra to show that the equalities hold true. And that's what we need for now.